Okay, so now we're ready to start applying our first toolpaths to this part. So, first of all, I just want to double check your role. So in this roles tab here, we're going to come over to industry specific and we're going to make sure we're on the CAM advanced role. This is just going to give you a lot more options at the top, and when you're not on the advanced one, it just hides a lot of features just to keep it a bit more basic. But yeah, we want all the options possible. Okay, so let's just make sure that's turned on. Okay, so this is the part where I'm going to start thinking about my first toolpath. So we obviously have 10 mil of stock on the ends, and we have just a little 2 mil from the top. So it's not just like a flash off the top. So straight away, I would be thinking of some kind of trachoidal milling toolpath, or a cavity milling toolpath. So it depends how you want to take this stock away. But for me, I always think with the depth of this not being that much, I would like to trachoidal cut the outside of this profile to rough it out. So sort of coming in like this and round. And I'll show you the differences between cavity and trachoidal in now. Okay. So let's go to our program order view. So the program order view, this is where all of our toolpaths are going to live. And we're going to need to add a new folder in here. So we want to keep it nice and neat. So you can either right click, insert, program. And this bit doesn't really matter. So this here is just a program folder. And I'm just going to call this roughing. And I like to put the stock that I go to. So I'm going to rough this to 0.5 mil. This is, you could just have roughing in here. It really depends. It's just personal preference. But I like to put the stock level in there because if it's a machinist who's reading this program, then I like it to be readable to them too. And this you can just ignore. Okay, so in that box that I just said to ignore, you could put some messages in there. So this is an operator message. So this is basically like an MO. It doesn't have to be an MO, but it's just a message that'll come through at the beginning of this folder. So you could put this folder contains roughing toolpaths, something like that, and then that'll just get dumped out with this all these toolpaths that live inside here. But irrelevant really, you can use it or you cannot. For this, I will use it, I guess, just to demonstrate it. Okay, so now we need to think about adding our toolpath. So let's have a look in here. So to add our first toolpath, we want to go to right click, insert, operation, or you can use this button here, create operation. So when we expand this type, you can see there's loads of different types. You might not see as many as me because I have everything. You might only have access to a few of these features, but the main ones that we are interested in is going to be planar, hole making, contour, multi-axis, and that's it. So I wouldn't worry about the rest of them. This is going to get you by 99% of the time, and obviously turning if you were going to be doing stuff on a lathe, but for this whole course is going to be based around milling. So what is mill planar? So mill planar are what I would call 2D toolpaths. So bit old school in the way that you would think about it. So anything that you would see from one axis like this, you could set profiles. So you could sort of pick this outside profile, and yeah, there's a few different options, but I would call these 2D toolpaths. I don't know where we got that from, but we're going to, create operation again. So mill planar, so you can see it's really nice when you hover over the icons. I mean, the icons are pretty good anyway. It gives you a rough understanding of what's going on. But when you hover it, you get a really good description of what this toolpath can do. So you can see here, you got a face mill toolpath, so you can just select a top face and it'll pretty much figure out for you the cutting pattern, and you can change it around a little bit. We'll go through these in good time. Floor wall, so that's going to machine floors, but it can also see the wall. These are more, I would say, like basic toolpaths, but mill planar is fantastic in my opinion. I use this a lot It's super versatile. It's really quick. It has like an automatic generating feature on there, so you make changes within the toolpath and you see it instantly. It's really good. So that's your mill planer. Then hole making is anything to do with feature-based machining. So this is something we're going to look into a little bit deeper. So we can specify these holes as a feature, and then all of these tool types or operation types will become available. So you can see you've got spot drilling, drilling, deep hole drilling, sequential drilling, spot facing. There's quite a few good options in here. And you can see again, you hover over and you get a super effective description, which is nice. Contour is going to be another good one that we're going to use a lot. So this is what I would call like a 3D toolpath. So it's creating surfaces, and you can see here you've got a lot of surfacing operations in here. Contour area, that's a nice one, really easy to use. Fixed axis guided curves, that's one of my favorites, really universal. You get some lovely toolpaths using this. Z level undercuts, your Z level profile. Quick roughing, yeah, so we can take a look at all this stuff in good time. So also your roughing toolpath. So these are your main roughing toolpaths here. You've got cavity mill and you've got adaptive milling. Plunge milling, quick roughing, rest milling. These are your sort of main roughing toolpaths here, but these, other than plunge milling, these two here are kind of adaptations of these two. So these are the OGs, as you would call them. Mill rotary, so this is like 4th axis sort of machining, so turn milling. Yeah, this could come in pretty cool in certain parts, but we're not focusing on this. It might come up a little bit in the course when we come to the 5-axis part, but not just yet. Mill multi-axis, so this is your 5-axis operations. So you got multi-axis roughing, multi-axis guided curves, so that's just the same as fixed axis guided curves, but you have the option to do some tilting tool axes. Contour profile, you might call that like a swarf cut or something like that. Streamline, again, you have a fixed axis streamline version too. Got some barrel milling, yeah, some pretty cool stuff in here. Tube machining, stuff like that. Multi-blade, not going to look at that. Yeah, okay. And just so you know, there will be future courses, so I will do maybe like a multi-blade course in the future, because it's quite a specific case. You use that a lot for like impeller machining and blisk machining, stuff like that. Yeah, so you can see here, and I really like this. I've used this before in the past when I've been doing impellers and compressor wheels and stuff like that, and it's a really intuitive bit of kit, this, and we will go over that in future courses. Okay, so for us, we want to rough this part out, so we want a mill contour path. And let me show you the difference between a cavity mill and an adaptive mill. So let's start with cavity mill. So we'll select the cavity mill toolpath, you can see it's highlighted. And now here, this isn't necessary that you fill this out, but I would recommend using it. It's a quick way of putting some information into the toolpath. So we choose here which program we want it to live in. So you can see this is our options here, and that is coming from our program order view over here. So we want this to live inside the roughing group, and that's why that was already highlighted. That's because I highlighted that to add the operation, so you can see it comes in with it. So tool, we don't have any tools currently, so we're going to add one in a minute. Our geometry, so we want this to live under the workpiece. If it doesn't live under the workpiece, it won't be able to see the body. It won't be able to see the stock, it won't be able to see the body. That's why it needs to live inside the workpiece. Our method, so this is our stock levels. So we want to use a roughing method. And now we're going to OK that. And just quickly while we're on it, so let's just see what that roughing method entails. So you can see here it's got a part stock of 1 mil, and I've specified in the program here that we want 0.5 mil. So I'm actually going to change this. You can see how it says locally defined, but that is actually inherited. So if we inherit that, oh, it has switched to 0. So when we change this to 0.5 mil, you'll see this padlock untick. Yeah. So now we're locally defining this. And our intol and outtol. How can I describe that? So let's go to paint, trusty paint. So your intol and outtol, if we are finishing a square block, and that square block looks like something like this, maybe not as wiggly as mine is, and our intol and outtol, what the intol will do is, with that being 08, you're allowing the toolpath to be here, like this, and because we have an outtol of 08, you're saying here as well. So what we're effectively saying is, this is the nominal line that we want to follow here. But with the intol and outtol at 08, this distance here is 0.8. And this distance here is also 0.8. So you're giving the toolpath anywhere to move within this line. And the benefit and disadvantage of this is, the bigger this gap is, the quicker your toolpaths are going to generate, because it's less computing time for the toolpath to figure out how tight it needs to be. The drawback to that is, if you're finishing a tied up profile, your finish and your size isn't going to be as accurate as you would like, because your toolpath can move by this degree of increment. And what I would say for roughing is, this is totally fine. For roughing, this is like no problem, because we're roughing to 0.5. So it would only, if we say 0.1 and 0.1, and we rough this block out to this stock level, at worst case, our stock would be 0.4. And at best case, our stock would be 0.6. So if you were roughing to, let's say our part stock was 0.1. For some reason, we were roughing to 0.1. And this is our intol and outtol. That's dangerous, because we could essentially be finishing the part in certain areas with this intol like this. So this is a bit of not experience, but it's very dependent on the parts that you're doing, and every company will work slightly different in how they like to rough things out. And some people will go to like 2 mil, some people go to 0.25. I personally, it depends on your material, it depends on how good your cutters are, how good your machines are. But for me, I think 0.5 mil is a pretty decent place to be for everything. So our intol and outtol, I'm going to say 08 and 08, which is fine. And this would just mean our toolpaths will generate a lot quicker. If we had a micron and a micron, our roughing toolpaths, I don't think they'll take ages, but they would definitely take 5x longer than it would at this level here, maybe more. It would still generate pretty quick, to be fair, but the more roughing toolpaths you do, it compounds. It will get slower because it's looking at the resulting stock. So okay, so we've created this, and we're going to change this slightly to just be a bit more user friendly, keep us up to date with what we're changing. So we're mil rough and 0.5 mil. So now you can see in this toolpath, I can see the stock level at 0.5 here, and this is locked, and you can see it's inherited from mil rough, and you'll see that here. So our method group, now you can see mil rough, 0.5 mil. It's very clear to me picking that. I know it's 0.5 mil. I don't need to worry about it. So now we're in the toolpath dialog. So just a quick overview. On the left hand side, you've got, let's call them groups. You've got groups that sort of make sense. So you've got your main, which is going to be the tool that we're using, our cut patterns, step over, depth of cuts, the main things about a toolpath. Your geometry is anything that we're looking at. So you can see here by hitting this part, we can see we've got the part highlighted. Just hit the blank, we can see the blanks highlighted. So geometry is anything to do with geometry, as it says, it's quite clear. You've got other things in here, but we'll look at that later. Tool axis, again, it's quite clear. This is our tool axis, the way that our tool is going to approach the job. So we're currently at ZM, which means the tool is this way, so we're pointing down. This is very normal in 3-axis operations. Speeds and speeds, self-explanatory. Cut levels. Cut levels is, you would say, your top of the range is the top of your block. So we're going to be starting from this part here, this face, and our bottom range would be this face here. Obviously, we're going to go slightly above that because we're going to be holding in some sort of vise. strategy. So this is like quite a detailed way. You're going quite deep into the toolpath when you start looking at your strategy, and we definitely will do this, and I like using the strategy a lot. We'll go into this in a bit. Non-cutting moves is, as it describes, anything that is related to the toolpath which isn't a cutting move. So this will be your approaches, your retracts, your traverses, transfer heights. You can set start and drill points if you want. Tolerance and clearance, this is going to be, so your tolerance, which is what we just talked about before, so mill rough, and the tolerance would be 0808. And your clearance is your collision checks. So when we get a little bit more advanced and we go on to the, especially the later course, when we're going to be using proper tools, this comes into play a lot more. We can collision check against certain things. And here you can just choose what you want to collision check against. Tool program machine control. This is more very detailed. This will be customer specific because everyone's machines will work slightly differently. But for us, we aren't going to use anything in this course related to this page probably. Options. Again, this is something you probably won't use a lot. We'll use the edit display at times, especially on drilling toolpaths, but not straight away. Okay, so we need a tool. So let's go to the tool tab. And for this, we're going to specify, especially for the early parts, so this part and the next part and part 3, we aren't going to be doing any detailed tool assemblies, or we're going to do very simple, very basic tooling just to get us through. We want to get programming now, don't we? We don't want to get a bit bored, so we want to, keep it simple. So here you can see I've got a generic machine in here. I don't want that. I'm just going to get rid of that. I don't think I have a machine in here actually. I'm just going to delete that carrier out. We don't need it. It just complicates things, and again, it's a customer specific thing. So I've never really used pockets and carriers in actual production. So now we have an empty tool list basically. So we're going to go to our generic machine. We're going to insert, and now we're going to add a tool. So you can see we're going to this insert page quite a lot here. And again, you've got the options up here, so use whichever you prefer. I have a space mouse as well, and I can also do it on there. So if I click a button on my space mouse, I get a couple of options. I would recommend, if you're going to do a lot of CAD CAM, I'd recommend purchasing a space mouse. Okay, so generic machine, we want to add a tool. So you're going to get a few different tool types dependent on the box that you select here, but for us, we are doing mill contour, and you can see you have this selection, but also if you go to mill planar, you're going to get roughly the same selection. So it doesn't really matter here. It only matters, let's say you pick turning, okay, now it's changed a lot, obviously. But yeah, and also hole making is going to change a little bit because you're going to get all the drills and stuff. But for us, we're going to be mill contour, and we want to specify just a milling tool. And I'm going to call this 16 mil end mill. And maybe like R1. So this is going to be a 16 mil end mill with a 1 mil rad on the end. So now you can see this dialog's popped up for us. So this is where we're going to specify our tool. So it's quite self-explanatory again. It's the diameter, we're going to want 16 mil. The lower radius, which is the radius part here, we've said 1 mil in here, so we're going to replicate that. So that's going to be a 1 mil. The taper angle, so we don't need that. That's going to be nothing because you can actually see here, it gives you a pretty good description of what everything means. So you can see B is this taper angle here, and obviously it's just a normal end mill. Tip angle, again, not important because it's just normal end mill. The length, let's say, 75 mil is fine. The flute length, so I mean on a 16 mil, you've probably got around 40 mil normally. And flutes, this is going to be, we're replicating alley, so we're going to say, let's say 3 flutes. And relief diameter, not important, but this is going to be your the relief between the shank and the cutting length. So if we specify this relief as 15 mil, and then the relief length at I guess 10. So now you can see we've got a tool which is a 16 mil diameter. We've got a 1 mil rad. The overall length, so from the bottom to the top here, is 75. Our flute length is 40 mil. So the yellow area, that's our flute length. So cutting edge, that's 40 mil. And we have a relief diameter of 15 mil here. And that is of 10 mil. So up to this point, it's 50 mil basically. And let's just give that a tool number of 1. Not that it's important for this course, but because we're not really going to post anything. But let's just keep it nice and orderly. So this is going to be tool 1. Shank, we don't need to worry about that yet. We're just going to keep it basic for now, and this will come into effect in a later course. Okay, and again, holder we don't need to worry about. For this part and up until the very last part, we're just going to focus on the tool. But when we come to the last one, the last part, which is more of a big project, we're going to actually look for proper tools and proper holders and stuff. So it's going to replicate an actual project. Okay, so let's just say okay to this. So we're building this up as we go in, and it might change as we go down because we're going to think about things a little bit. So let me show you the differences now between a cavity mill and an adaptive mill. So what we want to do is we want to rough this outside profile first. So if I just quickly go over my thought process with something like this, the way I would think about a part like this is I want to rough this outside shape first. I then want to get rid of these corners, these 4, and then I want to start roughing out this pocket. And I'd probably take off the top face prior to roughing out these pockets. Yeah, so I'd probably do outside profile, these little corners, top face, and then rough out these pockets. That's the way I'm thinking about this. And yeah, so let's get into this bit. So let's do a cavity mill. So we want to rough this outside shape first. So our tool is going to be the 16 mil. So path settings. So we've got a couple of options here. So follow part is going to follow this shape here. So you can see this outside shape. So it's going to follow the part. It's going to roll around it. If we were to rough inside this pocket, follow part would try to still follow the outside shape that it can see. Follow periphery will look at the cut area. So if we specify this as a cut area, it will see this and it will roll around that nicely. Profile is kind of irrelevant when it comes to cavity mill. It doesn't really make sense, but if we selected this outside profile, it would follow it. Not really applicable for this. Zig is, if you were roughing this top face, it would zig across, up and back, zig across, up and back, zig across. And zigzag would zig across, zig across, zig across. So zigzag is a lot more effective and keeps the tool down and cuts for longer. Zig with contour would be, you could select a line and it would zig and just follow the pattern. So it's basically a zig, but you can define the contour. So if you did like a U shape, then it would zig the U and then come back over and zig the U. Almost the same as profile, similar anyway. But for us, we're just going to keep this on follow part for now. Or step over. So you've got a few options in here. You can either just say constant. So you could say 10 mil step over with the 16 mil cutter. You can say a percentage of tool diameter. So we could also say 100%, which would be 16 mil. And personally, personally, I would keep this on constant. There's not many cases where you'd use the other ones, to be fair. Constant is just, it will always do the same step over that you define. You could say like multiple step overs. So you could say the first step wants to be 10 mil, the second step wants to be 5 mil, and the third step wants to be 2 mil, something along those lines. And it can come in useful, but not when you're roughing. And so, okay, so we're going to keep the step over constant, our maximum distance. So I like to use tool diameter, and I'm going to say The step over is going to be 75% for a cavity mill. Our depth per cut, so you can see again we have this similar sort of options. So flute length is always a good option, but you have to make sure your tool is modeled correct to the tool in reality. So I would say something like 85% of the flute. So in this case we're going to use all of it basically because the tool's quite big. Cutting direction, so on any modern CNC machine you're always going to climb mill. So you can conventional mill if you want and it'll force the tool to go the other way, but for us we obviously want to climb cut. So the cut order, so depth first and level first. So you can see when you hover over this you actually get a really nice little tool tip. And it gives you a good understanding of what's going to happen. If I was to, let's say we select this pocket, we want to rough this pocket and this pocket. So if you do level first and you set like 1 mil cut depths, it's going to jump into this pocket, it's going to do 1 mil, and then it's going to jump over here and do 1 mil, and then jump over here and go down to 2 mil, and then over to 2 mil. If you do depth first, you're going to get 1 mil, 2 mil, 3 mil, 4 mil, all the way down to the bottom, and then it switches, so that's a lot more effective. You don't want the tool jumping in and out of pockets, you want it just to rough down here, and then go to this and rough down there. So we're going to go depth first for this case. And you can see that would be really annoying as well if you're going to do, if you can just rough the whole thing out in one tool path. And we would then, if you did level first, then it would come round, it would rough this outside shape, it would then hop in, do one, come out again, do the outside shape. So it's a bit annoying. So for us, we're going to keep this at depth first for now. Okay. So coolant. So this is if you want to specify the coolant, you can say, this isn't really too important for us at the minute, but yeah, you would say coolant would be flood. So flood is out of the nozzles, through is through spindle coolant, mist is like you could use oil mist, and air through. And you can say open area. So for example, an example of an open area would be this outside shape where it's open containment. A closed area would be this pocket, we're enclosed within this area. Okay, so in process workpiece, whenever you are roughing, you want to use this. This is super important. If you don't use this, what's going to happen is you're going to, if we rough this outside shape and then we come in and rough these pockets out, if we don't use in process workpiece and it comes to rough these pockets out, it's not going to know this outside shape's been roughed. It's not going to be creating us an in process workpiece. It's like a stock, and we'll see that as we go down this line. Minimum material removed, we can go through that later on, it's not that important. You can just specify if the stock is under, let's say 1 millimeter, it will ignore it, and this is to stop it doing lots of little cuts that you don't think it needs to do. So by setting it to 0, that's like do everything that you could see, literally. Okay, so that's all set nicely. We're going to go into our geometry area now. So we have our workpiece already set. Part side stock is already set because that's been inherited from our half a mil roughing. So you can see if we hover that, it's inherited from mil rough half mil. Blank stock. So what blank stock will do, when you look down at your stock here, if you add 10 mil of blank stock, it's going to offset our part by another 10 mil. So this is useful in, normally it's useful in your first operation like we've got here, because sometimes, as you probably well know, a billet can hit the machine and it might be 10 mil bigger in reality than it actually should be. You might have ordered 100 mil thick, but the billets come in 110 mil thick. And what normally happens is the machinist would run it and your tool would take a really heavy cut and possibly break it or fling the job out of the vise. So blank stock, you can add 10 mil onto here or whatever you desire, and it will offset the stock for you and do bigger cuts. So I'll demonstrate that in a minute. So our cut area, let's just hide our stock so we just see the part. So our cut area, so we could say these faces. So you can see how I'm selecting them all individually at the minute, like so. So we can say I want to cut them faces, but to save a lot of time, I would always recommend you've got this little box up at the top. So you can say single face, tangent face, adjacent. You've got a lot of options here. But for this, we want tangent face. That's going to be really nice. So we can select that and it's done all of it for us because they are tangent to each other. So you can see it's added that. There's 8 items. So 1, 2, 3, 4, 5, 6, 7, 8. 8 faces that we've selected. Okay. We don't have any checks, so this would be, let's say you've got a vice that you want to include in check, so it avoids it, but for this case we haven't got anything. Trim boundaries, we're not going to have anything just yet. Okay, tool axis, yep, we're going to be ZM, we want to look down on the part. Feeds and speeds, so we're saying this is aluminium, and let's just say we've got a half decent, I don't know, DMG machine or something like that, so we're going to set this to, say, 12,500 speed and let's say 6,500 feed. This is obviously very tool dependent. It could be very different depending on what tooling you're using, but I'm just going off my experience and what I've done in the past. So, cavity mill, cut levels. If we say this, we could specify this as our top face, but in reality you can see that it's already taken it for us from this block. This is in reality our top of face, which is 17 mil. But NX is really good because it knows the stock block that we've got in our workpiece, so it already takes it from that top level for us. And you can see it would already select our bottom of the part too. It will do multiple in here normally. But for us here, we're going to just specify this locally. So you can see the bottom of the range it thinks is here. I don't know where it's got this from, but we don't want that. We want to go all the way past the part, don't we? So let's get rid of that. And then we'll select the bottom of the block. So now it's gone all the way to the bottom, but we don't want to go all the way because we're going to need at least something to hold on in the vise. So what you could figure this out in your head, so you could say, okay, 25 mil, I want 4 mil to hold on in the vise and maybe 1 mil clear, so that'd be 5 mil. So I want to go to 20 mil, you could say. Or one way that I like to do it would be, I would press that there and then just put your cursor anywhere, press end, and that'll take you to the end of the line, and then you can use this like a calculator. So now I would say -5, hit tab, and that's gone to 20. So I use this box like a calculator, and it's the same for most boxes in NX. So our depth per cut, thinking about this, I was sort of thinking along the lines of an adaptive mill in here. So I'm actually going to change this, and we're going to do 5 mil depths of cuts. Okay, you can see that's then brought that over into here. Our strategy, we're not going to worry about that yet. Non-cutting moves. So for closed areas, it's going to try and use a different, you can set different strategies whether it's closed or open. In this case, it's only an open area. So we're going to worry on open area here. And an arc sounds like a good idea. So let's do arc, and you can specify percentage tool diameter or whatnot. Personally here, I'd just like to use millimeters. So let's say 5 mil. Arc angle is just 90 at the minute. Height is 3. So let's just keep this, let's just keep it out of the box for now, and then we'll go in and tweak it as we see the toolpath. That's how I like to work. So retract is normally, yeah, the same as engage. So whatever you make here, the engage is going to be the same, and that's pretty useful for 95% of the time. Avoidance, don't worry about that. Smoothing, again, don't worry about that yet. We'll play with that after. So clearance options. So let's go in and set a clearance height. So this is going to be how far the tool retracts to. So you can see there's a few options in here. Automatic is normally pretty good, and we'll say 5 mil, and that will take it from the top of our plane here. You can see it knows where the top of our stop block is, so we can say we want to go another 5 mil from there. Let's go 10 mil just to be safe. You can also specify, so you could say I want to go from this plane here. You can see, because the stop block's on the screen, you can see I can't select the face of the part. So if you just stay still, and then you see the 3 dots have appeared at the cursor now. Now if I click, I get this options window. And now it's looking through the part. So now I can select that face. That's a good way of doing it. But for this, we're going to keep it on automatic. Okay, we'll worry about this after. Tolerance and clearance, again, we'll worry about that later. So now the toolpath's ready to generate. So let's generate it and see what happens. Okay, so this is exactly what I expected from a cavity mill toolpath. So you can see it's doing level by level. So let's look into this and see what these colors actually mean. So you'll see you have a yellow color here, you've got a white color, a green color, and a blue color. And this red dotted color and this blue dotted color. So the red dotted color is your traverse. So it's traverse in between moves. The blue dotted is your traverse, but your approach down to the engage. So you can see it. This is all a rapid move. These dotted lines are rapid moves. The yellow is your engage. So this is it engaging onto the material here. So if we just drop on, you can see we're engaging onto the toolpath. So if you just click the toolpath, you can see you've got this display. So you've got the two options here, display toolpath and select toolpath. If I'm clicking the toolpath here, I can't see anything. If I hit display, it'll all come on. Now you can also see I can't select the toolpath now because it's not enabled. If we hit select, now you can see I can drop into there wherever I like to see what the tool looks like in that area. Okay, so yeah, the yellow is the engage and the white is your retracts. So if we just, let's click the toolpath, let's verify the toolpath, and let's just hide the stock for now because we don't need it. So verify. So in the verify, this is how we're going to watch the toolpath. So you've got replay and 3D dynamic. I'll show you the difference. So replay, it's just going to come down and it's going to show us the toolpath step by step. Like so. You can also just click to areas that you're interested in at this point. So you can see I can just click and it's going to those lines. 3D dynamic is much better. I like it because I can see the stock being removed. So let's go to 3D dynamic. You've got a couple of options here. The ones that you're bothered in really are this speed button and suppress animation. But if you suppress it, you're not going to see the toolpath. This is more for looking at stocks once the toolpath's finished quickly. So let's watch this now. So you can see it's taking the corners away and then we're working down. Very traditional toolpath, I would say. This is what people would go to most of the time. And I'm going to teach you in this how to think a little bit differently and think outside the box and make you a better programmer. This is a very traditional approach to roughing out this. So let's show you what adaptive roughing will do now. So if I do an adaptive milling toolpath now, it's going to think this outside's already roughed because it's got this toolpath here. So what we're going to do is we're going to take this toolpath and we're going to dump it into unused. So now let's build up an adaptive toolpath. So again, we can either do create operation or right click and insert. Mill contour again, adaptive roughing. This is all fine, roughing again, 16 mil, workpiece. And our method will be mill rough. Okay, so just to go through these options again, the range type is slightly different in adaptive milling. So you can see here, we can specify our top level. It's already picked it for us from the stock block, and our bottom level, it's already done it again from our stock block, but we know we need to take a bit off that because we don't want to take the vice bit away. So if we just put our stock on just to see that. So we can see if I go select bottom object, I take that. And then again, I'll use this like a calculator if I want. So I can go end and then take away 3.5. Oh, sorry. End, because this is a minus, you need to plus. Oh, plus 7 now. End plus 7. Tab. That was plus 7. Don't know how I got that. Plus minus 7. Okay, 20. Okay, so now with a trachoidal milling toolpath or an adaptive, the step over is going to be different. So this is where I would definitely use percentage of tool diameter. And normally a 10% is very average for most cases. Like 10% is, I see that used in a lot of cases. So this is you can see the width of cut, and the actual tooltip here again is quite helpful. So I'll show you the difference here. So let's just do 5% to begin with, just so you can see the difference. So again, we want 85% of the flute at least. It'll always be one cut because you've got 40mm anyway. Top off flats. So we'll turn that off for now and we'll play with it after. Bottom up cutting, again, this is not really relevant just yet. Curvature radius, we'll leave that down. Yeah, and also let me know in the comments of this video, like, do you want me to dive into these topics here? So like talking about minimum curvature radius, would you rather me dive into that now and go deep into it, or would you rather me go into that at a later date just to get this moving a little bit, because I'm just a bit wary for time. I don't want to make 2 hour long videos on like one toolpath and stuff. But just quickly, top off flats, I'll show you how we can change that in a minute. And minimum curvature radius, that will you could set if you put that to 10mm, it won't go into a 8mm radded corner. It will smooth it out, so you don't get sharp toolpaths in the corners. It'll smooth it out as much as possible, and that is really helpful. So you don't get cutter breakages. If you have that really small and the cutter is going into a corner, you quite often find that you'll get a lot of tool breakages because the tool wraps around the corner. Let's just leave that at 10 for now. Okay, geometry, this is all the same. Yeah, that's all the same. Let's just turn on our 3D. Tool axis, that's the same. Speeds and speeds, not really relevant, but we're going to set it anyway. So let's say 12,500 and 6,500. Strategy. So, what direction? Again, all the same. Adaptive pattern. So, this here is if it sees a pillar. So let's just say this was a one block, and we were roughing it out. What happens is it ultimately comes towards a pillar in the middle, and a lot of tools don't like this. It's not as big as a problem as a lot of people make out, but it'll leave a pillar here, and then the smaller and smaller it gets, it snaps off, and that can damage the cutter. Here you can set it to helical. So what happens is when before it starts to cut, it will helical into the middle and then work its way out, and that way you don't get the thin region, but you still do get it on the outside. So kind of irrelevant really. I would always leave this to adaptive pattern most of the time. Okay, engage. So this is slightly different because it'll work out its own open engages. So we only really need to worry about closed area, but we know we're not doing any closed areas here. And then tolerance and clearance, this is the same as before. So let's generate that and see what we get. So you can see this is I like this toolpath. This is probably my preferred way of removing material. So you can see the differences between the two. This to me, it looks messy. I don't like all of these retracts and engages and traverses. I don't like that. This is much neater, I think, in my perspective. So if we watch this one, that's much more what I'm looking for. And now if we do this a little bit more realistically, so let's open up this a bit. So we're going to not do 5%. I would be more like for Ali, like 25%. So let's generate that and we can see the difference. So yeah, now we're only a couple of passes, and I'll show you what top off flat will do. So top off flat faces, it's going to see this top flat face of the part now. So it's going to try and get rid of it for us. But personally, I mean, it's not terrible. It's also seeing the flats on here as well, which is probably could be a good thing. But the problem is the top face here. So this very top face, I wouldn't do it as an adaptive toolpath because that's only 25% step over. 25% step over is actually pretty good for here, like this corner pocket and these corner pockets, and it's good for the outside shape, but I wouldn't say it's that good for this top face. So how can we like stop it from cutting this top face? Well, one thing we can do is we can reduce this height, can't we? So you can see we're saying start from this top level so it can see this top face here. So if we just move this, we can either drag it down. So you see I've dragged it past that face now. We'll regenerate it. So now it's ignoring that top face. The next thing I don't like is this, it's doing this first level first. So you can see it's cut out this pocket and then it's rolling around this corner to this area here. So let's just watch it. So you can see we've got a couple of options down here. Generate, replay is just a quick verify. But we can go straight to the verify bit here. And let's just play this through and see what we get. Not bad, is it? That's pretty good. But let's just check first. So we're using a 16mm cutter there. We need to see what rad this is here, don't we? Because we don't want the tool to be bigger than this rad, because you're not going to get it and you'll have to go in there with another tool, and that's just not efficient. So let's go over to our analysis tab now. So this is where we have the measure feature. You've got a couple of options in here. You can check radiuses, where this might actually come in useful. We can select a point on there and you can see it's given us a minimum radius of 5.5mm. I like to use the measure, and I'll just hover this and you can see it's giving me the radius there. Or you can click it and here you have the radius option, which you could switch to diameter. So you can see to finish this radius you'd need an 11mm diameter cutter. So that's actually not ideal for what we want, is it? So what I'm going to do is I'm going to come back into this toolpath and I'm going to reduce this height below this face so it can't see it. Or alternatively, we could just turn off top off flats. There we go. So this is the toolpath that I'm looking for. So I'm going to go ahead and delete this cavity mill for now. Okay. So now this area is done. Now I need to come in and I want to rough these pockets out, and I need to rough these little corners out. So thinking about it, the way I would like to rough these pockets out, again, you've got a couple of options. You have got a cavity mill where you can do level by level. To me, adaptive mill makes sense. I would like to rough down here and take it all out in a trachoidal pattern. So the next thing we need to do is check what these corner radiuses are. Otherwise, we'll end up in the same situation here. So really, whatever tool does this inside, we would like it to do this side as well. So let's go and check. So again, we use the measure tool and I can see 3.5mm. I can click and the diameter is 7. So we would need a 6mm cutter. So nothing bigger than a 6mm cutter. And I mean, ideally, a 6mm cutter might be a little bit too big, because one thing you've got to think about is, yes, we're using a 6mm cutter, but we're also applying 0.5mm stock. So we're really not allowing the tool to move much in this corner. And this is where the minimum curvature radius comes in the adaptive toolpath, what I was just talking about. Let me show you what a 6mm tool would do in this corner here. So the second thing to think about when you're roughing out a pocket like this is looking at this rad here. So this is a 1mm rad, so we want to match that. So we want to use a 6mm tool with a 1mm rad. So go into our tool tab. We want to add a tool. So back to our home view, create tool, mill contour. We just want a normal milling tool. And I'm going to call this 6mm end mill R1. So diameter is going to be 6. Our lower radius is going to be 1. 0, 0. Our length, let's say average length would be maybe 50mm. Our flute length, so for a 6mm, you've normally got around 18mm of flute. Let's say 3 flutes again. Relief diameter, let's say 5.5, and the length, let's say 5mm. So here is our 6mm tool that we've just made up. Let's call this tool number 2. Okay. So now you can either build up that toolpath again, or as you're going to be using another adaptive roughing path, I'm just going to use this and I'm going to copy it and I'm going to paste it. So now I see I've got the tool here, and now I'm going to go into the toolpath and I'm going to change the tool from the 16 to the 6. Okay. So what else do we need to change about this toolpath? Well, it's currently looking at that outside shape. So we need to now specify the inside pockets here. So in our main, our range type we're going to specify again, and our top level we are going to specify this top face. This isn't that important at the minute because we do have 2 mil of stock on the top, but with it being adaptive milling toolpath, it goes straight to the floor anyway. So it's not as if we're trying to look for any features above here, and we're not going to be doing that top face anyway. So I'm going to keep it like this for now. Okay, so our bottom distance, so here, this is going to be this floor. So another thing about the adaptive milling toolpath is it's always good practice to add your stock level to this floor. We'll try it with and we'll try it without and we'll see the differences. So we've got the floor selected. Our step over is going to be slightly less. Let's go down to 15% of the tool diameter. So that would be roughly almost 1 mil. It'd be 0.9 of a mil. Or you could just say 1 mil here. Doesn't really matter, but I like to keep it consistent. Our depth of cut, so again we probably want to use as much flute as we possibly can. So you could go up a bit more, but again you do need to make sure your tools are modelled up exactly like they are in reality. So this is all fine now, we don't need to worry about that. We'll keep the minimum curvature radius at, let's just say 1 for now, as small as we possibly can go. I don't know if you can go to 0, but no, you can't. So you can see I've tried to go to 0 and I've got this little warning at the bottom right. It says minimum curvature radius must be greater than 0. So let's just put 1 in there just for something. So geometry, this is all the same. Tool axis, this is the same. Fees and speeds. So when you go to smaller diameter cutters, you can generally go a little bit higher on the spindle, and you want to go a little bit less on the feed. So we're going to go down to like 250. Don't look too much into these figures. I'm just plucking them out of the air. Okay, so now this engage is going to come into play because we're in a closed area now. This is a closed pocket. So you can imagine on the outside, you can just plunge down and start ramping around because it's not in stock. When you're in the closed area, it can't just plunge into the stock. You're going to damage the cutter. So we're going to specify a helical, and you can say the diameter size now. So this is percentage of diameter. So if you do 90% of the diameter, or let's say you do 100 of the diameter, it's going to do a 6 mil circle and follow that 6 mil circle down as a helical move. You don't want to go ever more than 90% because if you go like 110%, for example, you're going to end up with a little pillar in the middle, aren't you? Because your tool's going at too big. You're doing too big of a radius and you're not cutting the center. So you never really want to go above 100. Your ramp angle, this is the pitch that it's going to go down in. So I'll change that in a minute and I'll show you how that works. So let's start at 5. Our height is how high above the job we're going to start. So for this case here, we actually want to start at least 3 mil above because we have 2 mil of stock and then we're going to be 1 mil slightly higher. So it's going to start ramping in fresh air for 1 mil and then start hitting. Minimum ramp length, this always has to be less than the diameter. And it's not that important to know, to be fair. Retract, again, doesn't really matter. So your part safe clearance, so we need it to be 5 mil-ish. Actually, no, sorry, 3 mil's fine because that's 1 mil above the top of the stock. And then our safe clearance moves, it's not relevant. But you can see on the picture here, it's kind of like holder collision, but it's not relevant because we haven't got any detailed models for our tools. So our low height transfers, this is going to be when you're doing a trachoidal cuts, and if you're doing like say this sort of pocket here, its first cut at 25% would be like a cut like this, and then you're saying then move half a mil above and wrap it across. So that's what makes it so fast. But you can specify 1 mil, 10 mil, whatever you like, but it's always best to be as low as you can. Okay, so let's generate this and see what we get. We could get some funny things going on here. Okay, that's pretty good. So you can see it's a really nice looking toolpath for roughing out these pockets. But take note of, this is what I was talking about the minimum curvature radius. This, you got to think, at 3,250 feet, this tiny little move is a lot for the machine. And you're going to get a really jolty machine. And you've probably seen it before on machines where a program will be running and you hear the machine, it sort of feels like it's moving, like it's like jumping around, and it comes from these fast little moves here. So this isn't good for anybody. It's not good for the machine. It's not good for the cutter. And in this case, you have to have it this low to force it into this corner. So that's why we're not going to use this tool for this application, but I just want to show you the difference. So now if we go into the main, and in the minimum curvature radius, let's specify 20% of the tool. What you're going to see when we generate this is this corner is going to smooth out a lot. There we go. So although we're now not getting all the way to the corners, so you can see we are a little bit away from it, this toolpath is going to be much smoother. It's not going to wear the cutter as much. You're not going to have that potential of breaking the cutter, and it's not going to damage the machine. This is a much smoother approach. And you can see this helical engage is 3 mil above. Or it actually looks a little bit more. But this is the kind of toolpath we want. So if we just verify this, and we'll see what we've got. So 3D dynamic, and we'll slow that down a bit. It was a bit fast, wasn't it? So you'll see the helical engage in like that. You see these nice moves, and you see how it cuts and comes across. These are the low height transfers I was talking about. Okay, speed that up and finish it. This is what we've got so far. So I'm not happy about the way it's roughed these corners out. And also, yeah, so I want to drop this tool down to 4 mil. So you can see, I'm not sure it saved my option. Yeah, it did. So we want to change the tool now. So rather than being a 6 mil, we're going to specify this as a 4. So we just change it like so. The relief diameter, because we put 5.5, we need to put this down to like 3.75, just something slightly under the diameter of the cutter. And now this will change to more like 12 mil. Yeah, that's okay. And remember that we need to change this here to 4 mil too. The name. Okay, so we can just go in and regenerate this. Because we specified percentage of tool as a step over and percentage of flute for here, it doesn't, this is the beauty of using percentages of things, that it stays the same. If this was 1 mil, then you might want to have to think about reducing that to like 0.75 or something that's a bit better. But when you use percentages, it's actually just the same. So we can just come in and regenerate this toolpath now. The top cut must be higher than or equal to the bottom cut. So for somehow our top distance has been lost. So let's just reset that. And let's reset that. I think that was 10. Yeah, that's okay. So regenerate that. And you can see now we've got a bit of a finer step over in here, but it's going right into the corner now. And we've still got the 20%. So it's still nice and smooth, but now we're roughing out the whole thing. We're getting right up to the corner. Obviously we're leaving 0.5 mil. Okay, nice. The next thing would be, we actually want to rough this area out here, and we could do it with this tool. It's not too much of a problem. Although we'd get a 1 mil rad in here, obviously we're staying off the wall 0.5 mil, and we would get a 1 mil rad in there. With it being alley, it's not a problem. Like that would get rid of it in the finished cut, like no problem whatsoever. So the easiest way to do that in here would be to add this top off flats. So let's add that and generate and see what we get. Okay, that's worked okay. That's worked pretty nicely. So now we're roughing the floors and we're getting these corners in there too. So let's see what our program's starting to look like now. So now we've got 2 toolpaths in here. We've roughed the sides and we've roughed there too. So now I want to start thinking about a cut to get rid of the stock on the top face. So let's think about that. So we don't want to use the 4 mil, but we could use the 16 to get rid of the stock on the top face because that's quite a big cutter. So let's have a look at what toolpaths we've got. So insert, operation. Probably don't want a mill contour for this. I'd be more looking at the mill planar options. So we've got face mill, zigzag, that kind of makes sense, doesn't it? Floor facing without a wall, that also kind of makes sense. It's kind of the same as that. So this to me kind of makes sense. We want to rough this top face. I do want to do it in a zigzag pattern. So let's do that. Or let's try it. It wants to live in this group in the roughing 0.5 mil. We're going to use that tool, which is fine. We want to be the workpiece and we want to rough. Okay. So let's see what dialog boxes we get here. So you'll see all the boxes are the same on the left. They always stay pretty much the same, the groups. You'll get a few different options from toolpath to toolpath inside here. So the cut area is going to be our top face. This is what we want to cut. Our floor stock, we want to leave 0.5 mil on there. So you can see it's created this sort of plane from the top face. It's showing you what it's going to do. So you can see the blue lines are what it's going to cut. And the red lines is showing you the boundary that it's going to reside within. So our cut angle is 0. So this is where you can tell it to cut in this length, or if we change this to 90, you'll see now it's changed the pattern here. You can change this to whatever you want. Be 45, it doesn't matter, but longest is best in this case. Containment, so we can say it needs to know how much stock is on this top face, because then it will work out how many cuts it does it in. So for this, you've got a couple of options. You've got thickness, which you could just say, hey, there's 2 mil of stock on this top face. Or 20, as I just mistyped. So yeah, there's 2 mil of stock on this top face, or you can say there is 10 mil, and it works it out from there. In our case, we have 2 mil. The other option is you've got blank geometry. So this is just going to take it from your blank. This is, in the past, been a little bit troublesome for me. If depending on how far down a program you are and how many roughing paths you've got and what your IPW looks like at that time, this can sometimes take a little bit of time to generate your toolpaths. I'm not the biggest fan of using this. And the same goes for 3D IPW. 3D IPW will automatically create you an IPW to the point of this toolpath, and then it will know how much stock's on the top face going down your program. It runs through your program and it knows what stock levels. It's very clever, and it's probably a very good option for simple parts like this. But for this case, I just like to specify, I know there's 2 mil of stock on this top face, so I'm just going to say 2 mil. The pattern, zigzag. So obviously you've got a couple of options in here that you can play with. Zigzag for me is going to be pretty good. Pattern containment. So you can see that's what this red bit's going to be. So outline or convex hull. It doesn't really matter because we're on a top face and it's not being contained by anything. Tool runoff. So if you hover over that, you can see how much it's going to run off the part, and we'll play with these afterwards. We'll generate something and then start playing with them. Your step over is the distance between the blue lines. So step over is percentage, 75%. That's great. That sounds good to me. Depth per cut. So if we say 1 mil, what will happen is you can see it's done 2 cuts for us because it knows that there's 2 mil of stock, so it has to do 2 1 mil cuts. In this case, we're just going to do 1 cut. So we just specify anything over 2. Okay, geometry. This is the same as you've already seen. You can see our part stock's actually got 0.2 in there. So that's because this is unlocked. It's been locally defined somehow. So that means this out of the box toolpath isn't inherited. So let's switch that to inherited. Now you can see it's being picked up from our method group. Avoidance, yeah, not important. Spindle speed again. So when it comes to like finishing faces and stuff like that, I normally drop this down. Something like this, a bit slower to finish the face. Strategy, not important. You see there's actually not much in there anyway. Non-cutting moves, we'll look at this in a minute. We're ready to generate something. My approach to building toolpaths is I like to just get something on the screen to begin with. So you can see now I've got something on the screen. Now I can begin to work with it. So what don't I like about this toolpath? So if we drop ourselves, so you can see we're not running off completely. I mean, that's okay in this case. I'm not the biggest fan. I would like it to maybe run off completely. Because what will happen is you'll end up with, you'll be able to see this sort of a pattern in the material here. Rather than like smooth line, 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 you'll have line, and at the end you'll get some sort of a weird marking. Not that it'll, like, it won't affect surface finish like whatsoever, but you'll just see this weird little marking here. So I would like my tool to run off completely. I don't like this height. So I don't know, I don't like the fact that it's engaging down here at the feed that it's cutting at, because I know there's no stock here, so it can just rapid for all I care there. And then run off. So here you can see it's running off by the tiniest amount. And here, that's okay on that side. So what we can do there is we can slightly increase our step over, and that will give you a bit of a better overhang there. Because you got to think we've also got 0.5 mil of stock on that face, so you might end up with a little pip at the end of the part. So let's see what happens if we just increase this slightly, like 80. So we've got pretty much the same outcome. Is that percentage of tool flat? Yeah. So the difference between percentage of tool flat is this 80% is working out from the 80% of the flat area of the tool. So it's not thinking about the radius. It's taking that out for you, which is it's really quite nice. It's a handy tool. Okay, so let's start looking at the things that I don't like. I don't like this height, so let's get rid of that. So that is going to be in your non-cutting moves. So let's go into the engage. So linear distance, which is this here. Let's do just thinking, I don't see the option for the height here. Is that changeable? Let's have a look through the options. So last pass overhang, that's that 2 mil here. Let's increase that. Oh, look at that, that's really nice. It's giving you a little dialog box of the last, that's pretty cool. So you can see it's 2 mil, but we do have a 1 mil rad on the tool. So let's just increase that to like 4 mil. Ah, that's much better. Yeah, that's nice. Okay, so that's that one problem fixed. The next thing is this tool runoff. I want to go a little bit further. So that's here. So you can see it's half of the tool. So let's say 100% of the tool and see what that looks like. So that looks okay. It's slightly too far for what I like. So let's try 75%. Okay, that's perfect. So it's rolling just off the material. It's coming around and cutting back on. Nice. And then onto this height. I don't see our height here. I don't know how we can control that. Normally, it's in your engage and retract. But let's just have a flick through. Yeah. Don't have it. So engage from distance. I guess if we set a plane. I wonder if we could set a plane from this face and then generate that. No, that's a bit wacky. Let's just leave it at distance. I mean, it's a bit far, isn't it? We could change that a bit. You can see it's running off really far. So let's just say 10% of the tool. So now it's running off only slightly. But I still don't like this little height. It's next to nothing. It's the tiniest of problems, but I don't like it. And I want to know where it's coming from. Is it coming from this figure? Aha! So it's coming from the part safe clearance. That's interesting. So yeah, this is more of a toolpath. I like this now. This is nice. Spot on. Okay, and we because we have the 16mm here, and then the 4mm, and then the 16mm, you're gonna have like multiple tool changes, and that doesn't make sense in this case. So let's drag this tool to be above this one, and you can see here it's saying it's the stock has changed because we've dragged this above this toolpath. The stock that it now sees for this toolpath is slightly different because now it's not got 2mm on this top face. So you can see it's gone ungenerated here. So you've got this yellow exclamation mark, which means the tool is up to date. So you can see the IPW has been generated, which is our stock model. You can see here there's no IPW because we can't specify. This is only a 2D toolpath, so it doesn't use IPWs and stuff. And you can see this one is out of date, so it just needs regenerating. Okay, there we go. Everything's nice up to date. So I think our part is completely roughed out now. So let's just run through our folder, our whole roughing folder, and see what we're at. It's looking good. Nice. Okay. So now this is the stock level that we're up to. So you can see we've got a button here to analyze the 3D IPW. So what this will show us is it will give us the maximum and minimum stock levels from our finished part. So this could it's really helpful. So let's have a look at what we've got. So yeah, I mean, this isn't very good at the levels that this is coming at. So let's reduce the number of ranges to like 3. And rather than having it as automatic, let's say user defined. So we'll say a minimum of 0 and a maximum of 1mm. Okay, so now you can see it a bit more. So you can see blue, this dark blue, so it's 0.68. So we are within 0.68 of the finished stock. You can see here it starts to go a light blue, which is I guess it's seeing that as fresh air because it's a hole, and it's light blue here as well because that's just pure stock. And then you can see this like purpley color coming in here, and this is coming in 1mm because you know we've got a chamfer on this top face, so this stock is slightly more than it would be everywhere else. But you can see in general it's quite a uniform stock. We haven't got any sort of slightly yellows and purples, and we're one nice uniform stock, and that's a dream for finishing cutters, because if finishing cutters are doing 2mm depths of cuts here and 0.2 depths of cuts here, you end up getting wear on the tool. And at least if it's a nice even wear like this, you got we're pretty much bang on 0.5 mil all over the part. It's just going to get a really nice even wear on your finishing tools. Okay, so let's cancel that. Okay, I mean, that's not good. That's our first error of the evening. Okay, so you can see it's created the facet body on our screen here, which that's because we analyzed it. It'll save an IPW. So where does that get put? So if we go into the part navigator, you have this box here called non-timestamp geometry, and it's not in there, which it normally is. That's where I'd imagine IPWs to go. So let's just delete it from the screen. So we'll change, you can see I can't highlight it now. So if we go no selection filter, we'll be able to select it. Interesting. Let's just go back and get rid of it. I just did Control Z then just to get rid of that. Okay. So I think this brings us to the end of this video. It's been quite a long video so far, and we've roughed out this part, and on next video we're going to start finishing it. Okay, well, I hope to see you in that, and I hope you've learned a lot. I understand this video has been quite long because we've been going through toolpath dialogues and stuff like that, but yeah, I really do appreciate the support, and I'll see you in the next video.